Okay, my outstanding friends, Roger, Mudfossil University. Today is final exam day. Now, get anybody that is intelligent and let's see if they can pass the final exam. Let's go into it right now because this speaks about mud fossils. Very difficult for the average mind to be able to let itself stretch to this border, which is a border of what we always consider to be myth and ends up being reality. Let's see if you can cross that border. All right, this is a tendon structure. It comes out in three big segments as a big tube, and then it splits off into all these little ones, and eventually anchors down inside the bone or wherever with a ball on each one of these little fibers, and they lock in. Just like if you could see in there, and you probably can't, maybe you can. Let me get a little light on here. If you could see inside that ball right there, that's a ligament. There, I probably can't see that. There's a ton of little holes in there, and what happens is there's a fiber that goes right into there, and then that fiber is big, but it ends up splitting into all these little fibers, and then balls on the end. They're enthesis, and they hold this bone over to another bone that's locked in the same way, so they can wiggle around and go back and forth. And the tendon moves. It doesn't stretch much at all. Tendons don't stretch hardly at all. That wrinkle zone, as I showed before, is they can if they pulled so hard, but boy, they want to come back. It's under tension, tendon, tension. Always very extreme tension, so that you can move around and do all this stuff, but poof, you come right back instantly. Very, very little give. I can't remember the percentage, but not much at all. Now, that is what we saw here. These are the same things as on whatever they call that place. I can't even remember now. But these are the giant fibers. Giant's Causeway. It came back to me. Now, they might be these, they might be these, they might be these, they might be these. But they're all polygonal formations. Let me show you what they look like on Earth. They're just absolutely gigantic. You see, here it is again. These are, you see these things, see here? That would be like this. Then you see the little bundles that are inside the big bundle? That would be like this. Or it could be like this and like this. They are at the, you have a bundle within a bundle within a bundle. That's what you got here. Bundle, 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 bundle. Every single one of these is coated what they call a fascially, subfascially. Every one of them has a coating around it. That's why they say separate. That's why you can move like this in your body and everything can move around and stretch and come back. When they harden up and turn into basalt, it's because the calcium carbonates, CaCO3, bonds with other types of minerals in here that turn it into different types of basalts and so forth. And all it is to become stable within a saltwater environment. It finds something that can bond with it to make it not rot away. And once it becomes stable, dries out, it just turns into rock. Okay, everybody's seen these. These are the hex fibers. They call them volcanic, intrusive volcanic, whatever they call them. Now, this can be tested. If you go down, there will be chemistry in here that can be associated to synovial sheath, which surrounds every one of these fibers so they can slide independently from each other. Let me show you an anatomical view of this anatomical, biological, geological structure of a giant. Now don't forget, wherever there's a wrinkle zone, it means it was stretched and then snapped. All right, so that's Devil's Post Pile. Let's see what we got now. Devil's Tower. What do you see there? There's the wrinkle zone. This is Devil's Tower. These are the tendons that run down the foot. Wherever you see this red, you see that red there? That's where blood supply is. There's an arterial blood supply up in this area somewhere, and one over here, and one over here. You have them coming up around your legs to go up to service, well, actually come down to service the feet. And these are the tendons, and you see them come snaking around here to go around the ankle. That's the wrinkle zone. This is Devil's Tower. I did a lot of research on it. I'm pretty secure. There it is right there. Now, you see all this red stuff around here? That is from the flesh, from this creature that died standing up in the flood, eventually fell over. This is the wrinkle zone at the top. It breaks just as flat as a pancake. And that's the way the heel is right here. These are the two heel bumps in the back of the heel. And the foot went out that way. The guy stood this way, and I don't know, some of them fell over this way, whatever. And I like I say, I normally do a pretty good investigation, and this is what it is. There's the heel bones right there, and the heel in the back. And these could come up to the side. Well, I'm not sure where I'm looking at this now, but somewhere, it's trust me, this is the wrinkle zone at the top. They break flat as a pancake. That is just the nature of the break zone. This is the fleshy part. See, this is down here is all red fleshy stuff that ran down from, because this is mud. This turns into mud. Red clay is mud. Tendon, totally different situation. Here's some more fleshy stuff. You see, there's the Devil's Tower. There's the fleshy stuff around it. He fell this way. What else we got here? Oh, somebody put this on. These are corn roots, and they put it on there. Oh, Devil's Tower is a tree. This is the problem. That's why I have to do something about getting the school certified, where we can validate that certain people have at least gone through the courses. They can do whatever they want after that. But if they've gone through the courses and seen what nucleophilic invasion is all about, and all of the minerals and metals and anatomy and all this, there's the wrinkle zone. This wraps right around the ankle. This is the ankle. Blood coming out. Everywhere you see something growing up here, that was a spot where there was some little blood vessels running. They eat the blood. They love the blood. They love blood. And there's different types of blood, or different types of, where are we now? This is, hold on a second. All right, let me explain to you. The blood, there's two different types of blood in your body. There's the arterial blood, which is the red blood that has oxygen, it has all of the vitamins and minerals and metals in it. And then you have the vein blood, which has almost all that same stuff, but then it's got some nasty stuff in it, and the carbon dioxide, and it's not like red blood. Well, one of them is called hematite, and one of them is called magnetite when they harden up. Hematite is the red blood. This is what happens with hematite. It wants more, these mossy things. That's growing right in where I can feel the depression where the bone would have been in this. You can see, actually, see the bone right here? You see there was a bone right here? I don't know if you can see that in the, if you can or not. But anyway, that's what, red blood grows this kind of moss. Black vein blood grows the lichen. When you see lichen on something, it's growing where the black blood is. We have new species. New species, they call them no-toes. And they have actually springs. They have springs. You see that? In the feet, and this is what makes the foot go up and down. This is the thing right here. I have this in my shop right here. Tish Egerton discovered that. I have a bunch of, these are mine here. She has a bunch of hers too. They're everywhere. This stuff is everywhere. It's nothing special. It's about time we start looking at it. It's just been avoided, and it doesn't fit in what they want to see. But if you can't see a bone there, and if you can't see where there was a pattern of a bone here, even though now it looks like it's just sandstone. Well, that is what's called nucleophilic invasion. This had the toes in it too. It was a no-toe. I believe this was a no-toe. And this one absolutely is a no-toe. And it has the springs still inside. But I have these here. This is what is inside of the heel. That's the heel. That little strap right there runs up just like you see here, from the heel up to the bone here. So that strap would have run up to the bone. It sits in this saddle here. All right. And this is the springs in the front. I looked at this very carefully. Very, very interesting. Very interesting. Anyway, we have a whole lot of new things to investigate. There's no reason not to do it. I mean, you know, the only thing you could do is just be scared, or you just don't want to know. That's all I can say, because I have DNA tests and CAT scans and anatomists and specimens and chemistry, and I recreated the process and all that. So it's time to bring it into the mainstream, other than just to keep it all like a crazy guy in the woods doing this crazy research. No, it's not crazy research. It's real research, and it's true research. It just happens to be, it really changes things. So things change.